All right, so now we're going to talk about the F-test. So we can also do hypothesis testing on multiple samples by examining the variance, and we're going to use the F-test metric, so as defined below here. So let's go ahead and let's do the same type of comparison test, and let's examine A and B and see if they are different at a 95% confidence interval. So let's go ahead and do we can calculate this value pretty straightforward. It's just the standard deviation. And actually, let's go ahead and calculate for this first one. So I'm going to go ahead and say, let's do SD of mat A, and we're going to square this divided by SD of mat B, and we're going to square this. Hopefully we get 0.29. Good. So what we can do now, if we're comparing, we can use our F-test, our var test. So let's just make sure we have our stats package built in. So we can go ahead and do var.test, and we can look at mat A, bracket 1, and we can look at mat B, bracket 1, and let's do it at a conf level 0.95. We're going to do alternative equals 2.sided, and that should be enough. And look at our F value, degrees of freedom, and we see our P value is 0.04. So when you are doing, and actually we can kind of put this over, we can look at this over here. You can look up a theoretical F value, but those tables are awful. They are very, very, very arduous, unfortunately. But again, this is a two-tailed test. So we can take our last couple steps and we can say that, again, our alpha value of 0.025, but our P value was 0.04. So we know that we're going to fall in a do not reject region because it's a two-sided test. And F tests are indeed by nature they are going to be two-sided and will actually divide by 2, which is different from our chi-squared test that we ran up here, where we're never going to have basically a true two-tailed chi-squared test. So let's go ahead and see, let's ask the question, is A less than B, or is A smaller than B at a 90% confidence interval? So let's go ahead and move over here, and let's do, and you can see that the order, it's just looking at the ratios here, so order really doesn't matter. Confidence level 90%, we're going to do, though, less. So is it less? So if it's 0.90, so let's go over here. So if we're looking at a 90% confidence interval, that means our alpha, ooh, why are you deleting? Why don't you want to stay? Here. Okay. Alpha is equal to 0.1. So we can look and see that's going to be the value there. Let's look at our, so 0.01. Actually, the alpha would be 0.1. Excuse me. So we are going to be in what? We are definitely in the reject. So we are for sure, we are, not we care. We are in the reject regime for sure there. And you can do greater than as well. And I bet you that's going to be in a very large do not reject. So we can actually calculate this. We can do this 90. We can do greater. And yeah, that's a big old do not reject right there. Excellent. So this is your F test. Moving forward, we're going to look at essentially looking at different variables and looking at our chi-squared test of independence. So we'll see you then. Thanks. Bye.